Alright, I promised you 3 examples for understanding permutations and combinations. Example 1. Example 1, let's consider a task. The task is you have 10 books. You just got a new bookshelf. Okay? However, maybe somebody gave you the bookshelf, you didn't buy it. So they don't know how many books do you have. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yeah. So but however, the bookshelf could only fit 6 books. Could only fit 6 books. Okay. So yeah, one slot, number 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So your task is choose or select. Randomly select. Okay. Randomly select. Select 6 books from the 10 books and put the 6 books on the shelf, on the bookshelf. Example 1, your task is to randomly choose, okay? Randomly choose. Choose 6 books from the 10 books that you have and put them on the bookshelf. Let's see how many different options do you have. Find how many different ways do you have to complete the task. Alright, so this task includes 6 parts. Do you agree on that? Part 1 is you choose the first book and put it here. Part 2 is you choose another book and you put it here, and so on. So you have 6 parts. So the task, this is a 6-part task. I just randomly select the numbers. You can try 20 books. Your shelf fit like 12 books. You can choose other numbers. I just randomly choose those numbers, and they are they are still okay. They are convenient. So this is a 6-part task. We are going to apply the fundamental counting principle to find a number of different ways that you can complete the task. Okay? Part 1. How many different ways you can put a book here? How many different ways do you have to put a book here? You have 10 books. You randomly select a book and you put it here. So how many ways do you have to complete that part 1? You have 10, right? Part 2. How many different ways do you have to complete part 2? You have a book here already. So now you only have 9 books. You choose one, randomly choose one from the 9. So you have 9 options for the part 2. Do you agree? When you go ahead to select the third book, you only have how many left? You have 8 left. You randomly select one from the 8 books and you put it here. And you see the pattern already. You know what's the rest. And when you choose the 1, 2, 3, 4, the fourth book, you only have 7 left. You have 7 options, 7 different ways to complete this part. And by 6 and multiply by 5. When you take the 6th book, you have already 5 books on the shelf, so you only have 5 books. you can consider. So you have 5 options for that part. All right. So is that a permutation or combination? Does the order of the books matter or not? The order of the books matter. Okay. It's like when you sit in the classroom, you sit next to A and you sit next to B, they would be different, right? So the position of the books, the order of the books on the shelf matters. So this is a permutation. This is a permutation. And the number of different ways to complete this task is a permutation P10(6). P is the initial of a permutation, right? 10 is the total number of items you have. 6 is the number of items you are going to choose to make the permutation. So this number is the number of ways to randomly select 6 items from 10 items and make permutations. This is the number of permutations. You choose 6 items from the 10 items. While the value of the permutation P10(6) equals this product, but you can just multiply them by calculator. But even better, we have a function in the calculator, TI-84 calculator, could help us to find the value for P10(6). Let me show you. Let me turn on the calculator and clear everything. We should go to math. And do you see those menus? 1, 2, 3. There's a menu PRB. PRB represents the probability. Okay? And you can see that number 2 is NPR. NPR is the function we are going to use to compute the permutation. But before doing that, let me quit it. We have to enter the value of 10. In total, we have 10 items, right? So you enter the bigger number first, and then you go to math probability and choose number 2, NPR. In our example, n equals 10, r equals 6. 10 is the total number of items. 6 is the number of items you are taking from the total number of items to make the permutation. And then you enter number of r, which is 6. And you have, what is the number? Let me write it down. 1, 5, 1, 2, 0, 0. Let's double check. If we multiply 10 by 9, by 8, by 7, by 6, by 5, we do have the same value. But using the function PNR, we can find the value faster. Okay? That's a permutation PNR. Let me explain the notation one more time. PNR. R is less than or equal to n. N is the bigger number, R is the smaller number. NPR is the number of different ways of randomly selecting R items from the total n items and make a permutation. Put them in order. In other words, put them in order. How many ways when we choose R items from n items and put them in order? How many different ways we can do that? This number of different ways. Okay, once again. This is the number of different ways that we choose R items from n items and put them in order. That is NPR. We can find the value by using a calculator. That's example 1. Example 2. select 10 books from 10 books and put them in the bookshelf. Well, now you tell your friend, the shelf 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you tell your friend the bookshelf that she gave you too small. Then you have 10 books, right? So now he gives you a different bookshelf. It fits all your books, right? Then how many different ways that you have when you put the 10 books in order on the shelf? So the order does matter, right? The order does matter. So let's apply the fundamental counting principle to solve this problem. This is a 10-step or 10-part task. Part 1, you select one book here, put it here. How many different options? Part 2, put the book here. Now you have 9 left. Part 3, you have 8 books left. Choose one of them to put it here, right? Part 4, you have 7 left. You have 7 ways to do that. And then multiply by 6, 5, 4, 3, 2. And after you put 9 books on the shelf, you only have 1 book left and no option. You have to put that book here, right? 1. You have 1 option for that. Okay? So by the permutation notation, this number is supposed to be equal to P1010. Do you agree? The reason we take this as example 2, they in essence actually is the same, because this is a special case of example 1. And we have a different notation for that. That is 10 factorial. 10 times 9 times 8 all the way to times 2 times 1. That is 10 factorial, right? Yeah. In a calculator, we have a different function for finding factorial, the value of factorial. Let me show you. So you enter value of 10 first, and you go to math, probability. Number 4, function number 4 is a factorial, and you choose that. That is the value for 10 factorial. If we multiply 10 by 9, by 8, by 7, by 6, by 5, by 4, by 3, by 2, by 1, you have the same result. If we try 10p10, we have the same value. Do you see that? They are all the same, right? Yeah. Either way, choose the one that you feel easy. That's the second example. Factorial. Factorial is a special case for permutation. It is a permutation. It's just R and N equal to each other. R and N equal to each other. So you can see that as a factorial. Maybe this way is faster for some of people. Example 3. So one day you're going to go on a trip. Don't go now, I mean, during the pandemic. So you need to pack your luggage. So this is your suitcase, right? So you determine, you have 10 books, remember. You have 10 books, so you how many books do you want to take with you? How about 3? So you want to pack 3 of 10 of your books and put the 3 books in your suitcase. In this case, does the order matter or not? You pack 3 books in your suitcase. It doesn't matter. Okay, you imagine you can pretend you use a big spoon to scoop 3 of the 10 books and dump them in your suitcase. How about that? Then the order of the 3 books doesn't matter because you are not reading or selecting when they are in the suitcase, right? So we don't consider the order here. The order here doesn't matter. Order doesn't matter. So this is gonna be a combination. All right. You select 3 books from the 10 and dump them in the suitcase. That is a combination. Then how many different ways you can complete that task? This is your task. Find how many different ways to complete the task. Well, let's see, how do we find the value? How about let's pretend order matters first. If we do concern the order of the 3 books, then we would have a permutation, P103, right? Do you see what I'm saying? Let me think. Yeah, this way. How about this way? If you do consider the order, then you would firstly take 3 from 10 books. Okay, let me explain what is a C103. This notation represents the combination, the number of combinations when you select 3 items from 10. That's the value we are looking for, right? That's the value we are looking for. That's the first step. So you choose 3 books from the 10 books without considering the order. And now you have the 3 books. And then you put them in order. Do you remember that is 3 factorial? And that gives you P103. Let me change the way to explain it. Let's pretend that the 3 books, the order of the 3 books matter. So that's supposed to be a permutation, right? P103 permutation. We can complete the permutation in 2 different steps. Step 1, you scoop 3 books from the 10. Randomly scoop 3 books from the 10. Since in this step, the order of the 3 books doesn't matter, that is a combination, C103. C is the initial of combination. In the second step, now you have 3 books, right? You put them in order. Is that clear? So this is the number of permutations. How many different ways you choose 3 from 10 and put them in order? That is equivalent to you choose 3 from 10 and then put them in order. Do you see what I'm saying? So C103 here would be equal to P103 over 3 factorial. This formula makes the calculation of combination doable. And also it helps you to understand the connection between combination and permutation. But even better, you know, we have a calculator, right? We have a calculator. So how do we find the C103? By the way, C103 does not consider the order. You have 10 books. You randomly select 3 books, put them in a suitcase, dump them in a suitcase. Then there are this many ways to complete that task. So in order to compute the value, we use the calculator. we enter the bigger number first, 10, and then go to math, and then go to probability. And the third function, number 3, is NCR. If you understand NPR, you should have no problem to understand NCR, right? The notation. And then enter the value for R. You take 3 books with you. And that gives you 120. Let me write it down, 120. So we can double check. Let's see what is 10P3. 10P3.